All right, guys, welcome to lesson 4.2. In this lesson, we're going to be talking about graphing quadratic equations in standard form and also in vertex form. So we'll start off by doing it for quadratics that are in vertex form, and then we'll move on to talking about how to do it with quadratics that are in standard. Now it says here for the ones that are in standard form, we're going to use a graphing calculator. Now, most of you guys don't have graphing calculators, so that's okay. Don't worry about it. But instead of using graphing calculators, what we're going to do is we're going to use a website called Desmos.com, which a few of you guys might already be familiar with. So, all right. Once we graph them, we're going to also talk about how to identify minimums, maximums, and y-intercepts and x-intercepts. So first of all, let's go ahead and talk about the graph of a quadratic. It looks like this. It's like a U shape, kind of. It's called a parabola. All right. So that's what the graph looks like. Now, the lowest point on the graph is called, in this case, is called the vertex. And the vertex can be either a minimum, which is a lowest point, or a maximum. So here's a picture that's coming up a little bit later in our notes, but the vertex can be a minimum or a maximum. So in this case, it would be a minimum since it's at the bottom of the graph. But if you had one that was upside down, then in that case, your vertex would be a maximum. Okay. Now, the places where it touches the x-axis are what's known as the roots, and the place where it touches the y-axis is what we call the y-intercept. Now, technically, the roots have other names, and you might want to add this to this slide. It's also known as the zeros, or it's also known as x-intercepts, of course. But the x-intercepts have different names, so you call them zeros or roots, right? All that being said, let's go ahead and some more stuff here. Now, how do we graph a parabola? Well, parabola looks like this, right? But we can do transformations to it, right? We can do the transformations that we learned back in our second unit where, if you were to subtract a number from the x, that's going to translate it to the right or left. You can add a number outside the parentheses, that's going to translate it up or down. You can multiply it by a number, which is going to stretch it or compress it. Or if it's negative, it will actually flip it upside down as well. So we have all those transformations in place. Now, after you do those transformations, basically what ends up happening is that the h and the k, just like whenever, oops, let me get that out of the way. Just like whenever we did graphing absolute values, the h and the k put together make up your vertex. And once again, the h is going to be an opposite sign from what you see in the parentheses. So since that says minus h, when I write this down, it's going to be a positive. Okay, or it'll just be the opposite of whatever it is. Next, this thing here, this is going to tell us what direction our graph is going and whether it's wide, stretched, or normal. So I'm going to give you guys a little chart here to help you make a decision about the general shape of the graph here. So if you have a positive a value, then you have a happy face parabola. That's if a is a positive 1. Now, what if a is a positive number, but it's bigger than 1? If a is a positive number and it's bigger than 1, well, that's a vertical stretch, and so it's going to make it look a little bit skinnier. And if a is between 0 and 1, like a fraction value, then it's going to be a vertical compression, so it will look wider. Now, the wide, stretched, and normal shape stays the same if a is negative, but the difference is that if a is negative, it flips it upside down. So if you have a negative a, but it's a 1, it's normal and upside down. If you have a negative a, whose absolute value, ignore the sign, whose absolute value is greater than 1, well, then it's going to be stretched still, but it's going to be upside down. And then finally, if you have a negative a whose absolute value is between 0 and 1, it's going to be wide and down. So basically, you have to look at two things when you look at the a. What is the sign? Positive or negative? If it's positive, it's a happy face. If it's negative, it's a sad face. And then you also have to decide, is it equal to 1, greater than 1, or between 0 and 1? If it's equal to 1, it's like a normally sized parabola. If it's greater than 1, it's stretched and skinny. If it's between 0 and 1, it's wide. And you might be wondering, well, what's normal? Well, normal would be this. So now we're just eyeballing it. We're not being really precise here. So I'm not too worried about how precise you are when you're making it wide, skinny, or stretched, or whatever. I'm just worried about the fact that you do understand that that's what the transformation does. So we're ready to go ahead and we're going to try to graph one here. So I'm going to walk you guys through the steps how to do that. All right, so the first thing that we're going to do is we're going to identify our vertex. My vertex in this case is going to be a positive 2 because we do the opposite of the h value, and a negative 3 for the k. So when I graph this, I'm going to put a dot at 2, negative 3. And that dot is going to represent my vertex. Okay. Now the next thing I'm going to do is I'm going to use my a value. Now notice it's negative, so it's a sad face parabola. And since the a value is a half, it's between 0 and 1, it's going to be a little bit wider than normal. Okay, so with my vertex here at this point, I'm going to draw a parabola that is upside down and slightly wider than a normal parabola. And I'm not being very precise on how wide it is because it doesn't really matter. I know we're not being that picky. But if you want to be picky, you can always just plug in numbers for x. Like we already have the vertex, right? We have 2. So if you wanted to, you could plug in 1 and you could plug in 3, the two numbers that are closest to 2. And that way you can find some points that are close to the vertex, and that way you can get a better estimate of what the actual look like. But honestly, that's not necessary. I just want you guys to know how to find the vertex, how to know if it's upside down or right side up, and whether it's technically in your mind, whether it's been stretched or compressed or not. Okay, so I'm going to let you guys try one of those. Now, before we get started here, I just want to draw your guys' attention to the fact that on number 2, we are missing some numbers, right? It doesn't look quite right. So I'm going to fix it up for you a little bit here. We have an x, right? And it's being squared. But notice that there's nothing in the parentheses with the x there. That's my h, and when the h is missing, it's 0. And whenever the a is missing, it's 1. So just to remind you guys really quick, if you're ever missing numbers, then if it's a, it's 1. If it's h or k missing, then there's 0. All right? So go ahead and pause the video here and give those two a try. Okay, so for number 1 here, it's your vertex would have been at 3, negative 4, and it's a happy face parabola, but it's stretched. So I put an S here for stretched. For number 2, the vertex would have been at 0, 3, and then it's a normally sized parabola, but a happy face one. Right? So that's graphing in vertex form. And we've already talked about this slide. Now, the next one is I want to show you guys just how to graph a problem in Desmos.com. And then from there, I want you guys to identify the vertex, the max, the min, the y-intercept, etc. So what we're going to do here is we're going to go to our internet browser, and we're going to type in the web address bar up there, www.desmos.com. Then you're going to click on Graphing Calculator. And then we're going to basically be typing these functions here into this window here on the left. And then we're going to be able to answer the questions. We're going to graph the parabola. And then we're going to identify the vertex, the minimum, the maximum, the y-intercept, and the root. So first of all, we need to put in -half. Now, whenever you type a fraction into this thing, you need to, well, I guess it does it for you. Never mind, I was going to say something, but it's kind of irrelevant. Then we're going to do x squared. Now, to get squared, you're going to push Shift and then 6 on your keyboard. And that, once again, it's Shift and 6. It's a little button. It looks like an arrow pointing upwards. But Shift and 6, and it makes an exponent. And then you can push 2. And then you got to push the arrow button to get out of the exponent now. And then we'll type the rest of it, 4x minus 11. And there's my parabola. So it's graphed it for us. Kind of nice, huh? From there, so there's our graph. So if you were doing a homework problem or something, you would just kind of sketch what that looks like. Now they want us to find the vertex. Now, usually, if you just kind of hover your mouse over it and then click on the vertex, it'll tell you what the coordinates are. So my vertex is 4, 3. So I'm going to go ahead and write that down here for part B. 4, -3. Vertex. Next, it says find the minimum or maximum value. Well, before I do that, let's first of all ask ourselves, what is this? Is this a maximum or a minimum value? Well, that's the highest point on the graph. So we would call that a maximum value. So let's go ahead and circle that and cross that off. And what is the maximum value? When we're talking about minimums and maximums, we're talking about the y value. So in other words, what's the highest y value? What's the maximum y value? And the answer there is the y part of the vertex. The answer is -3. So we have a vertex. We know this is a max, and the maximum value, in other words, the highest y value is -3. Now we want to find the y-intercept. And once again, the graph, if you just hover where it touches the y-axis, that will tell you the answer. So I'm getting -11 for that. -11 would be my y-intercept. You can write it as a point if you want to. The x value at that point would be 0. My y-intercept is 0, -11. Next, we have to find the roots. Now, the roots are where it touches the x-axis, but as you guys can see, the parabola does not touch the x-axis. So we're going to put NS here for no solution. Okay, so this is really just about using technology, but also identifying parts of parabolas, okay? Let's go ahead and do the next one there, number 2. Now I'm going to type in this parabola. Close that out. Type in a new one. So 2x, and to get the hour, once again, you push Shift and then 6. Type in your 2, and then arrow out of the exponent. And then -16x plus 36. And there's our parabola. And once again, we're going to go ahead and identify all the parts. So right down here, we have our vertex, which is 4, 4. Now in this case, this point is at the bottom of my parabola. So that would be a minimum value, not a maximum value. And once again, it's the y value that's the minimum in this case. The minimum y value is 4. The y-intercept, once again, they've highlighted for me right there, is 0.36. 36 is the y-intercept. If you guys notice something interesting, on the last problem, our y-intercept was -11. On this one, it's 36. That's usually what's going to be the case when they're in standard form. Okay, last one is we want to find the roots, and once again, there's no solution. Darn it. Oh well. But let me show you guys something here. Let's say I want there to be some roots. Wouldn't it be nice if I could just shift this graph down? Well, in Unit 2, we learned how to do transformations, right? So to do a transformation, don't you just subtract a number from your function? So what I'm going to do is I'm going to put minus 10. And that shifts the graph down. It's the same graph, it just got shifted down 10 spaces. If you want to, you can combine the 36 and 10 and just make it 26. You'll have the same thing. But in this case, for this one, now you can see the roots. The roots for this one are 2.268 and 5.732. That's where it touches the x-axis. Okay? But you don't have to write that down on your notes. I just wanted to show you since neither one of my examples had roots. So anyway, there you guys go. So I'm going to let you guys try doing one of these. Oops. Don't peek at the answers. I need to. All right. So go ahead and graph these on Desmos and see if you guys can find the all the appropriate values. Okay, pause the video here, and then when you unpause it, I'll have the solutions up for you. All right, so I'm going to go ahead and graph both of these for you guys really quick. There's the solutions. We have negative x squared minus 6x minus 8. So your graph for number 1 would have looked like this. We have our roots and our y-intercepts, mins and maxes. I've got all the answers recorded here for you guys. And then we also have the other one. I'll graph right now, which is negative 3x to the power of 2 minus 6x plus 1. And there's that one. So we've got our y-intercept, we have our roots, and we have our vertex. Okay. And so those are your answers for how to use a technological device to do these kinds of problems. I would have preferred to have shown you guys how to do this on a graphing calculator, but we don't have access to those right now, so Desmos will have to do. Besides, Desmos is a lot easier, actually. But anyway, that is that. Now, if you actually do have a graphing calculator, especially a TI-83 or TI-84, these are the steps on how you do it. And if you're a really, eager math student, you want to figure out how to play around with your graphic calculator, you can use the steps. You can also look it up on YouTube. The reason why I would encourage people to do that is if you're going into calculus next year, being familiar with your graphing calculator can make life a lot easier. Anywho, just thought I'd share that with you guys, and that pretty much closes out this lesson.